Hi, I'm Nick.
And I'm Danish. We're both software craftspeople at Codurance.
And today we're going to do a walkthrough of how to test drive your code in Python by solving the tennis kata. But not only that, we will also be showcasing pair programming and test-driven development. For anyone who wants to attempt this kata, you can find the link down below, which will take us to the Codurance website itself. I'm going to briefly describe and introduce this kata. So again, if we just scroll down, we can find the instructions on screen. A game is won by the first player to have won at least 4 points in total and at least 2 points more than the opponent. Scores from 0 to 3 points are described as love, 15, 30, and 40 respectively. If at least 3 points have been scored by each player and the scores are equal, the score is deuce. If at least 3 points have been scored by each player and the player has 1 more point than his opponent, the score is advantage for the player in the lead. We've also been given an interface below here. One thing to point out is that this is in Java, and we will be implementing the code in Python. However, we will be sticking to the names tennis score calculator and score where possible. Great. So now that we know our problem, let's move over to the IDE and start implementing our solution. So firstly, we have created a project already using IntelliJ. Feel free to use any of your preferred IDEs. So as we can see, we have source and test folders on the left-hand side, along with a version of Python, which we can see in the pyproject.toml. Here we are using 3.10. Another thing to point out is the package manager that we will be using is Poetry. Inside the README, all we have done is we have taken the instructions and the kata from the website and inputted it here just so that we don't need to keep scrolling backwards and forwards. Danish, is there anything else you'd like to mention?
Not a whole amount. All I want to mention is that in the pyproject.toml, we've taken the time and added PyTest as our unit testing framework, which we will be using to test drive our solution.
Great. So what we'll do first is we're going to head over to our tests folder, and we're going to create a new file, and we're going to call this test calculator tennis test tennis score calculator.py. Amazing.
What's our first test case?
That's a good question. I think we should be testing love all. When both players enter 0-0, so at the beginning of the match. I think that's like the most logical thing to test first.
So it's like the initial state, essentially. Right?
Yeah,
okay.
Yeah, definitely.
That works for me.
Cool. So test scoreboard should return love all when both players have 0-0 or 0-0. Both players scores or 0-0.
Have score of 0.
Both players have score of 0.
Yeah.
Have score of 0.
Yeah.
Amazing. So one thing I do like to do is begin with the assertions first and work backwards. This kind of just helps to jog my memory, get my brain into gear, and think about what I want to achieve. So assert result equals expected result.
Mm-hmm.
So from here, I like to say, okay, so the expected result should be love all.
As a string, yeah.
What do you prefer? Do you prefer lowercase a or capital A?
Capital.
Capital.
Yeah.
Okay, let's keep it capital. And then our result. So our result here, we are actually given this interface for inside the README. So if we just go back, our class name will be called tennis score calculator. So what I'm going to do is I'm actually going to take it from there, and I'm going to paste it here. And as we just saw, the method will be called score. So let's initialize that first and call the score method on that. Now for its parameters. Player 1, score, and player 2, score. Amazing. Don't be just be aware that you will get a lot of red lines, and that's completely fine. When you are test driving your code, you haven't actually created the implementation. You haven't actually gone to create the tennis score calculator. So as we move forwards, these red lines will begin to disappear.
That's the whole point, I guess.
Cool. So now,
score calculator.
yes, tennis score calculator .py. Amazing. So again, I'm going to be very lazy, and I'm just going to take it from our test, create a class, and from there, let's define the method. So def score, taking two parameters, player1 score,
which is an integer.
yes, and player2 score.
Also an integer.
Yes. Something to point out. We do like to use type hints because it makes everything more readable, more maintainable, and as well as the return type itself. So this should return a string. And for now, another thing I like to point out is when we haven't implemented our tests, our implementation just in the beginning, raising a not implemented exception error. Not implemented error kind of helps for readability purposes in a stack trace. So as we'll see, if we go back to our tennis score calculator, of course here we do need to import our class, and we of course need to create our player1 score. So let's go ahead and do that. Player1 score equals
0. That was the scenario.
And player2 score equals 0.
Another thing I wanted to ask, should we be making these parameters like named parameters?
Yes, definitely. I agree. It would help with readability, wouldn't it? So let's go ahead and do that. So player1 score equals player1 score, and then player2 score equals player2 score.
Awesome.
Amazing.
So good to go.
Great. So if we scroll down, we should see the not implemented error. There we go. Now just imagine a massive enterprise code base where you have lots and lots of classes and lots and lots of tests. This would be so much easier and more readable than just sticking out a pattern. So that was the thought process behind putting in the raise not implemented error. Great. So now that we have done that, let's go ahead and create our first test, create our implementation for our first test. So what is the simplest thing that we can do to make the test green? And that would simply be returning love. Oh, I believe it was a capital, wasn't it?
Capital, yeah.
Returning love. Oh,
yeah.
So
we run our test.
Let's run the test again. Oops. Let's rerun the test again. And great. So that's our first test, and that's in the red-green refactor cycle. And now we move over to the last part, which is the refactor stage. Looking at this code so far, is there anything that we could refactor?
I don't think there is anything to refactor at the moment. It's just too simple, and we're only just starting out. So I don't think there's any opportunities to refactor at this point in time.
Great. Okay. So now that we've done our first test, let's move on to the next one. So
yeah,
def test scoreboard. Now, what do we want to achieve? What do we want to test? Scoreboard. I would say let's pretend score 1 in the scenario scores a point, then that should return 15 love. So if it's 1-0, the scoreboard should be 15 love.
Yeah.
Okay.
Sounds good.
So test scoreboard should return
15 love.
Love.
When score is 1-0?
Is 1-0 for player 1 or too long, too much?
Might be too much.
Okay.
But it's probably sufficient.
Okay, let's keep it simple. Amazing. Same process again. So starting and beginning with our assertion. Assert result. Result equals expected result. Now,
That's fine.
expected result equals 15 love.
Yeah.
Okay.
Do you want to hyphenate that to separate scores essentially?
Perfect. So
15 hyphen love.
I'm guessing the left hand side representing player one, and then the right hand side representing
player 2.
Amazing. Okay, so 15 love.
Mm-hmm.
Okay, great. So once again, exact same thing. Result. Tennis score calculator. Dot score. Player one. Again with our named parameters. Player one score. And then implementing player 2 score as player 2 score. Great. So now let's create our player 1 score. Player 1 score. And this one is 15 or 1. This one is 1, isn't it?
Yeah.
Great.
We've got
2.
Got one there.
Player 2 score. I can't. My typing skills are 0.
Yeah.
Great. Player 2 score. Amazing.
So if we run that, what should we expect?
Let's run the entire test suite. Let's go for the entire test suite. Why not?
Oh, you might want to run the whole test suite.
Yeah. Let's go from here instead. Okay. Great. So first one is passed as expected.
Yeah.
Great. So yeah, as we can see, we are getting love all because we haven't actually implemented our second test. So yeah, let's go ahead and do that. What we want to do is we want to have multiple scores. So for example, love and 15, and be able to select from that. And then depending on what the score is, kind of just pocket which score we want to implement.
Okay.
So let's have a scores. And then from the scores, we can have love. Love, or should this be love all? No, it should be love, shouldn't it?
Should be love.
Okay. And then let's go onwards with 15. Amazing. So if player 1 score, we can start by doing the simplest thing possible. So if player 1 score equals 1, and then from there we can build and refactor into a more sophisticated solution. What's your opinion on that? Or would you rather go straight?
I would have done the simplest thing. And we can do that here as well. So let's see if we can do the simplest thing. So we can check if the player 1 score is 1 and player 2 score is at 0, then simply return 15 love.
Okay.
And perhaps we can then refactor into your suggested solution.
With the scores?
Yeah.
Okay. So let's go for that then. Player 2 score equals 0. And then from here, we can just output or return 15, or it would actually even be better if we create an F string with...
Well, now you can use the scores that you have. Player 1 score?
Yes, player 1 score. Player 1 score and self.
The hyphen needs to be outside.
You're correct. Definitely correct.
And close bracket there. Open a new one there.
Amazing.
Perfect.
Self.scores. And then player to score in here.
Okay, that looks good.
Great.
I've got confidence in this. It should pass.
Again,
Brilliant.
amazing. On second thoughts, I believe we can still improve this solution. So here, I'm not quite liking this. If equals 1. So what if we change it? So if player 1 score is 0 and player 2 score is also 0, yes, we've broken the tests. However, what we can do is we can make this solution even better by replacing the format, the f string, and moving this f string down below. So replacing the f string with the log O. And if the execution doesn't actually invoke the if statement, it then goes down below for
So
the f
that's
string.
passing now. That looks good.
Any other ideas for a refactor?
I was also thinking that if we turn our attention to the test suite, refactoring shouldn't just be limited to our production code. I think we can also refactor our test suite a little bit. So looking at this, I think we can, I can already see that there's a little bit of repetition here, and we could probably convert this to a parameterized test, which means that we don't have to keep declaring new set of tests, but only add test input to and not have to recreate the repetitive test essentially.
I hear you, because we will just end up doing 15 love, 30 love for everything.
Over and over again.
And then again, creating these these tennis score calculator objects would just be a lot of duplication. Okay, so let's go ahead and do that.
Okay.
Cool. If it's okay, I'm going to do it at the top. So def test scoreboard should return expected result when player scores given player scores result given player scores. Okay. So again, for now, what I'll do in this scenario is I'll stick a class, and like you mentioned, let's go ahead and create our parameterized test. So at pytest.mark.parameterize. So this is the basic syntax for using the parameterized tests within PyTest. Now, do we need to import PyTest?
We do, yes.
Okay.
It's already there. Okay.
Already there. Okay. Cool. Great. So first, what we need to do here is put our inputs. Parameters. Okay. So player 1 score. Player 1 score. Player 2 score.
And then expected result.
Which
is exactly the same as the three variables declared in the tests that we had before.
Perfect. Yes.
Cool.
Yes. So then our next thing would just be a list of tuples representing our 3 parameters we just declared. So in our case, let's do 0, 0, representing the first test, and this to equal local. Perfect.
And then I guess you can take these 3.
So just passing them in as parameters themselves.
Yeah, looks good.
As well as the expected result. Amazing. So
I think you just need score calculator instantiation.
Great. Yes. So what I'm going to do is I'm going to be really, really lazy. I'm going to rip this from the bottom. And instead of our expected result,
We don't need these declarations anymore.
exactly, it becomes even easier. Indent.
I think that's it.
Amazing. Okay, so I believe that should pass.
And it is passing.
Great.
Can we expand the this test case? Because so
Amazing.
brilliant. So we can replicate the other tests as well now, and simply just remove these tests that we don't need anymore.
Great. So the next one is 15 love,
Yeah.
which is 1-0, I believe.
Yes.
Okay. So again, all we have to do is add another tuple of 1, 1, 0,
And 15 love.
and 15 love.
Yeah.
Great.
Okay.
If we can just format that. Great. That just gives us a better look. The tests are still passing, so that's a great sign. And because if we open this up, we have love all and 15 love, we can now get rid of these redundant test cases.
Yeah, we can just keep adding new input and expected results.
Okay. One thing I am going to do here, if you don't mind, I actually prefer the tuples to be one on top of each other. So if I move this to the bottom, it makes it more readable. So I feel like if we add another scenario for
a bit of a separation.
Yeah, it's easier on the
Easier to
eye,
read.
like downwards than across.
Works for me.
Great. So before we carry on even more, we can actually refactor this even further. So maybe if we put this on a new line and brackets there, bring this to the front. How do you feel about this? What's your opinion on this?
That's infinitely more readable.
Okay, perfect. Cool. So for our next scenario, we should probably go 2-0 and 3-0. So
cover off all the trivial cases,
Okay,
Works for me.
and that's for player 1. Yes, so 2-0 and 3-0 for player 1. Cool.
Should we be covering it for player 2 as well?
Yes, I feel straight after we finish with player 1, we can then move it over so it's 1-0 to player 2, 2-0 to player 2, and so on.
Yeah, it's fine.
Okay, cool.
So what's this one then?
This one,
30 love?
30 love. Amazing.
Let's run it. It's failing, that's fine, it's a good sign.
Let's see. Oh, why is this failing? So in the scores, we actually haven't implemented the case for 30. So
It's very simple now.
let's go ahead and add 30 in there.
Yeah, just should run any minute.
Amazing. So
Great. Back to green.
is there anything we can refactor?
I don't think so. I think we've kind of got ourselves in such a rhythm that so far it's quite clean. So we're just testing all the trivial cases. So I guess what's the next one that we can add?
I believe the next one will be 3-0. And this will be 40 love.
Yeah.
Amazing. So I do expect this to fail.
Yep.
Perfect.
And I guess that's just a case of adding 40. Great.
Great. I think now we'll do what you suggested earlier, where we check for player 2. So we've checked all of the trivial scenarios for player 1. Yep. Onwards for player 2. So this time we'll do 0-1, and it should be
love 15.
15.
Great. Should it pass? It should.
It should, shouldn't it? We have everything in place.
Yeah.
Okay. The next one.
Yeah.
Love 30.
Yeah.
Okay.
That looks great. should pass as well. Yeah, and it does.
Nice. And for our final one, 0, 3, love 40.
Just rinse and repeat now.
Such an easy process with parameterization. Imagine doing 6-7 different test cases.
When you can do it and when it applies.
Definitely. Yeah.
Okay, so it's looking great. And what's the next thing we can do?
So I think the next step would be to begin implementing Juice. Let's take a look at the README again, just to verify the instructions. So I believe this is the line that we want. If at least 3 points have been scored by each player and the scores are equal, the score is Juice. Which means player 1 and player 2 scores are equal, and if they are at least equal to or bigger than 3, then it's Juice. Okay. I believe that's doable. Let's focus on the happy path first. So let's go for 3, 3.
Yeah.
And this
should be
Juice. Okay. Juice.
Yep.
Okay.
So that will fail, obviously.
Perfect. Let's just take a quick look at the failing test to see what it says. 40-40. There we go. So we need to implement that to reduce. Great. Now,
let's do the simplest thing.
Okay. So if player 1 score equals player 2 score, and I think I'm going to sneeze actually midway through. Nope, it's okay. Let's carry on. So if player 1 score and player 2 score is equal to each other, and player 1 score is bigger than or equal to 3.
To 3. Yeah.
And player 2 score is bigger than or equal to 3.
Yeah.
Awesome. Score is, let's return Juice. Okay. Great.
Back to green.
Amazing. So, again, red, green, refactor.
Okay.
Time to refactor. Can we make this better?
I think so. I think we can probably extract this condition into something like a much more readable, perhaps a private method.
Okay.
Yeah, I think that's something we should do.
Great. So let's create a private method, and let's say the private method is called isJuice.
Okay.
isJuice, and within this private method, we're going to take in player 1 score. Again, int player 2 score, and again this will be the int.
And get a boolean back, I guess.
A boolean back or a string.
Boolean.
Yes, we will be getting a boolean, and then we will be returning a string. Okay. So here, what we'll do is
extract the condition that you have on line 7.
Even quicker. Okay. So we can take this entire thing. Oops. Convert, C, and then in here. Is there any way we can make this line 1 yellow?
You can. Do we need to do a return?
We do. We need to return everything. Okay. So obviously, I don't believe in magic numbers.
Yeah.
That's one thing.
So I guess this is the minimum threshold for deuce, isn't it?
Yes.
Minimum score for deuce.
Minimum. So let's create a variable, a constant.
Yeah, we also need to use this method on line 7.
We do. Okay, we've got quite a few things to do here. Which one should we go for first?
Use the method first.
Use the method first.
First things first.
Okay. So if it's juice,
give it the scores in the method.
Yes, of course. So player 1 score is player 1 score, And player 2 score is player 2 score.
Yep.
Great. Next, should we move on to the method itself?
Magic numbers, right?
Magic numbers, yes. Okay. A constant within the class, or do we want to do it outside of the class?
Outside should be fine.
Okay, let's go for outside then. So, minimum threshold score. Okay.
Yeah.
Minimum score
for deuce.
And this is
3.
3.
Looks good.
Great.
Let's use that.
Let's take this and replace the number 3. I am going to format this because it is getting a bit long. So let's try that.
There you go.
So nice. So anything else? Can we go a step further?
I'm not seeing it. What's on your mind? What are you proposing?
So clearly, yeah, I'm completely with you. I don't think there is anything in terms of the implementation itself. How about no?
Yeah. One quick. Well, I guess another test case that we can add, maybe, if there's only factor to do,
definitely
would be: would you still have a deuce at 4-4?
Still have a deuce at 4-4. Okay.
Okay, so that's another condition covered.
Deuce and 4-4.
Okay, so that should pass.
Amazing.
I
would like to add a Vines test here for 5-5, if that's okay with you.
Yeah, go for it.
Yeah. So 5-5. Just to cover the happy path.
Yeah.
Great.
Okay.
So clearly the happy path is done. My question to you now is, what if it's 2-2?
2-2. That
2-2.
should be 30-30. Right?
30-30. Okay. Let's also do that. Let's try that.
Let's add that, definitely.
2,
in case we break something.
30. I think that's okay.
Yep.
Okay, everything is still passing. And just to verify that, let's take a quick scroll. 3-3, 4-4, 5-5, and 2-2.
Yeah.
Okay, perfect. Next.
Yeah, I think the next condition for us to do is the advantage stage, where, let's have a look at the README, where one player a player has one more point than the other.
Okay. So just before we do that, let's switch pairs. So
yeah. Happy to take the keyboard.
Cool. Now the README itself, I believe it's line 21. You're looking at it.
Yes.
Okay. So if at least 3 points have been scored by each player and the player has one more point than his opponent, the score is advantage for the player in the lead.
Okay. So I suppose at this point we can add our condition, which is 4-3.
4-3. Yeah.
And says advantage player 1.
Advantage player 1.
That's how they say it in the tennis games, right?
Yep.
Player 1. Okay. And this will fail, obviously.
Okay. Yep. As expected.
Yep. I'm gonna change something here, and I'm gonna go split right. Okay. So
I kind of like that, just a little bit of left, right.
Yeah. So I mean, this is hardly going to change. Our production code is going to change a lot more.
Mm-hmm.
So even though you can't see, nothing's changed. We will just keep adding newer conditions. Right?
Okay.
Okay, so let's get player 1 to advantage. So simplest thing, if condition. So you can say if player 1 score is more than player 2 score, and I guess
they both are at 3 or above.
Yes.
So the minimum score, I believe, so they need to have at least a deuce. The minimum score for at least a deuce.
Yeah. So I think we can probably reuse this one. And player 2 score is also having more than or equals to the minimum points for deuce. There was one more condition in there, wasn't it?
Yeah.
Which was the score difference.
The score difference.
And player, this is going to look very, very crazy, but we will hopefully clean this up in the refactor stage. Advantage. If I can type. Advantage. There. 1.
Okay.
All right.
Nice. Very nice. So all tests are passing.
Yeah. So everything's green. Now, I'm not really liking this thing here. I think we can probably extract this into another method of some kind.
I completely agree. Okay. I think we could do something like instead of player 1 minus player 2 straight in the if condition, we can say score difference. So we can have a score difference of where we pass in player 1 score and the player 2 score.
Yep.
And from there we can calculate the difference.
So let's create another private method. It is at advantage. So we can clean everything up in there. So it's already looking a lot better. So nothing is broken, everything's passing what we'd expect. So let's break this up a little bit more. So let's do this one first. Score diff. Score diff equals we probably don't need these brackets. So that's that one. I don't think we need that at all because we're kind of covered here, and then this will tell us whether somebody does actually have an advantage. So we're already we were already looking a lot better at this point. Do you think that we could? Is there anything more to refactor? If not, I have another test in mind that I'd like to do, which is giving the advantage to player 2.
Okay. So one thing I do want to say is, are we happy for saying minimum score for duos? Because now, if this is minimum score for advantage, again, yes, the constant will be equal to 3. We are introducing a bit of duplication by having 3 twice.
Yeah,
However,
so
it does increase.
Dependency, yeah.
Yes, readability.
Okay, I think we can probably separate the two things out a bit like this. It will be infinitely more readable. And it will be like this.
Amazing.
Okay. So nothing broken, harmless, refactor done, readability improved. Okay. So if there's nothing else to clean up at this point, my suggestion would be, can we try and test for player 2 advantage?
Let's do it. Happy paths.
All right. So it would be 3 and 4, so just inverted condition there. 2.
Mm-hmm.
Okay.
Failed.
We're getting a fail. And why is that? Okay. It's perhaps because it's not falling into this condition. And I think I already know the reason why that might be. It's because I think it's because of our math here.
Agreed. I believe we're getting -1.
Yes.
So
That's probably why.
yeah, by just adding that absolute around it and wrapping player 1 score and player 2 score, we can get a positive.
Okay. So now we have the nice problem of formatting, I guess. So we've gotten through this condition, but we're now, because we've hard-coded advantage player 1, we are not printing advantage player 2.
Yep.
Right? So I guess at this point we have to identify which player does actually have the advantage. So if it's okay, what I would like to do is I would say player with advantage is self.player with advantage. So it's essentially just to get an identifier out of
course,
this whole thing. Okay. And what I would like to do is use the F-string.
F-string, yes. Yeah.
Actually, let's put this whole thing in there. So we can print player 1 and player 2. The method doesn't exist. We're still in the red. Add a method. Let's be consistent. Add our type hint. So what we will actually get is the identity of the player with advantage. So we will get a string back. And so what we do here is that is that advantage. Okay. So I think that's quite simple. So we say return player 1 if player 1 score is bigger than player's 2 score. Else return what?
Player 2.
True. Should that get us to agree? Yes.
Perfect.
It does. Perfect.
Okay. If I may, I would like to mention one thing for the refactor.
Yeah.
Just for consistency. Is that advantage? Let's add the type hits for
that's
player 1 score and player 2 score.
Just thinking that's a very good catch. And this is a Boolean.
Yep.
Okay. So it's looking great.
This might be a little bit picky. Completely up to you. How do you feel about the magic number on line 23?
Line 23? Yes, absolutely. What would you propose that we name this?
Score difference. If score difference is equal to score difference.
Let's do an extract. It's working. That's okay. Technical glitch. Let's go to refactor and introduce constant, and we will say score diff advantage. For advantage.
Yeah, score difference for advantage.
For advantage. Spell that right. Did a good job there. Okay, so score different for advantage. That's looking good. Do we have any more magic numbers that we can get rid of?
Honestly, I don't think so. There is the obvious 2 zeros on line 10.
They're quite distinct. I don't feel like they should go. One more refactor that I think I can already see is these these underlines are kind of bothering me. So I'd like to make these methods static because it's not accessing any kind of properties of the class itself.
Yep.
So, okay, so it's already looking clean.
Okay.
Yeah, okay, that's it. What's the next thing that we need to do?
So I believe we're at the place where we can look at the win. Let's go back to the README.
Yeah.
I believe it's the first bullet point. A game is won by the first player to have won at least 4 points.
4 points in total.
And
at least 2 points more than. So it's kind of like the advantage functionality that we added this condition, except that the thresholds are a little bit different.
Yeah.
Correct?
Yeah.
Okay. So let's, in our usual fashion, let's add a test case. Okay. So what would this be?
I believe this one could be 6-4 to player 1.
6-4. And what would we like to print?
Player 1 wins.
And
player 1 wins. Yeah.
Wins. All right. So this should fail because we don't have anything for this. Okay, that's fine.
Okay.
So let's see if player 1 score is more than player 2 score, and score diff is what? 2 points.
2
more
points.
than 2 points, right?
Yeah, can't be 3. Has to be 2. 2 points. So if player 1 score more than player 2, player 1 is more than player 2, and score difference is 2, and they must at least have 4 points.
At least 4 points.
4 points? I believe yes. It did say 4 points. I'm not.
Yes, it did.
Not going crazy. Okay.
It does. Yeah. More than equals to, I guess, 4, and player. This is probably going to look horrible for a few minutes. Okay, let's add this thing. Also separate this out here. So if let's read this once again. If player 1 score is more than player 2 score, actually, do we even need that? We probably don't.
I believe. So if we only have a score difference of 2, and the player 1 score is more than 4, and the player 2 score is more than 4,
and the score difference is.
But then we could have the player 2 could be 6, and the player 1 could be 4. And right now we're trying to test for 6-4.
Yes. I'm perhaps jumping ahead. Let me dial that back. Okay. So score difference is something we don't have at the moment. Should we take the same approach and do that? So player 1 score minus player 2 score is difference of 2. Then what do we see? We see that the player 1 wins.
Yeah.
Okay. So that looks legit.
Nice.
So that's
very nice.
That passes straight away.
Okay.
So I think the very first refactor opportunity that we should actually do is extract the method. Okay, and we will say is game 1. This should also be a private method. Okay. One thing I've not done is keeping in line with the other formatting. So let's just do that very quickly.
Just the name parameters. Fine.
So let's go to this method here, and we've got a whole bunch of magic numbers. So what's the very first thing that we can look at? So I guess this is the minimum score required for the win. So I'm actually going to introduce a constant here.
Yeah, I was about to say.
Okay, both occurrences. minimum.
I believe there's a
Yeah, minimum score for
win. Yeah.
win. Yeah,
Yep.
and this was score diff for win,
Yeah.
right?
Score difference for win.
Score diff for win. Okay. I think just like so again, everything is passing. I think this condition is a little bit redundant, isn't it? Because we're protected by the absolute score. This condition here.
Let's try it and see what happens.
Yeah, sure. Okay, let's get rid of that.
We can always put it back as the test.
Oh, why am I doing that? Okay, so that should
Nice.
be green.
Okay, that's perfect.
So a lot cleaner as well.
Right.
I would like to put this on a new line.
Yeah.
All right. And this is what we do then. I'm going to extract this. I don't like doing this in place. So it's a score diff and have score diff here. Let's get rid of these brackets. Everything should stay the same.
Very nice.
Okay.
Just before we add another test case,
Yeah.
I know this will be picky once again.
That's fine.
Type hints. I
Of
think
course.
when we do create this method, or at least when the ID creates it, it doesn't add the type hints.
Yeah. Okay, I think this is looking great, and I think I can do one more thing here is to also make this static, not accessing any properties, and it's looking a lot cleaner already.
Perfect.
Okay, can we now move on to getting the player 2 to win?
I think so, yes.
All right.
So it will just be the exact same thing, but instead of 6-4,
Yeah.
4-6.
4,
6.
6, comma. Okay, this should fail.
Yeah.
And I think this is, again, same kind of thing here that we were getting a -1 or -2 in this case. So we do need an absolute score difference here. And perhaps, now
You're guessing.
the ID of the player that's won. I think this method, player with advantage, gets us exactly what we want. The naming may or may not need to change. So let's tackle that in the. Let's tackle that in a second. So player with advantage. This is an F string, and should be green. Yeah.
We could call it player in the lead.
That is a good name. You're in the lead, if you're an advantage or whether you're winning. Say with lead. All right.
Yeah, player with lead.
Cool. I think I have one more thing to do using the named parameters. Okay, so it's looking great.
Do we still want to call the variable player with advantage in is game 1?
No, I think we should call it player with lead. Right?
Player with lead. Okay. Because I do feel in the context of is that advantage, player with advantage is a good name.
Yes.
But yeah. Player with lead.
Okay, so this is great. I'm seeing one more thing, which is the score difference is exactly the same.
No, I totally agree.
Should we extract it to a method?
Yes, definitely.
Okay, and say
score difference. We're filling score difference. Reducing duplication.
Great. Oh, this is my bad. What did I do there?
Perfect.
Score difference.
We have a
this is interesting. We don't have a self because it's a static.
Yeah.
So I suppose we need to put this back in at this point. Okay.
I believe it's the same on line 42.
Actually, can we just put this in our module?
I like this approach. I really like this approach. Yeah.
One score, which is an integer, and layer 2 score also an integer, and we get a boolean back. Oh, sorry, not boolean back. Get an integer back. And then what we do is, I believe we can't have it private because it's like that. Okay, and then I suppose we move. This kind of disappeared, didn't it? Oh no, it didn't disappear. I do apologize. Let's take this one. Don't need this at all. Okay. All right. Everything is
back on track.
Yeah. Okay.
So I believe we've implemented everything the instructions are saying.
Yeah.
To point out, we haven't implemented anything to do with minuses. So if you pass the calculator -1 and -1, and scores with a bigger difference, such as, let's say, 10, 20, or 30, 40. Now, guys, feel free to do this kata in your own time and have fun implementing those test cases if you wish.
Yeah, and make your solution much more robust. So with that, I think, thank you very much for watching.